Okay, welcome to my video on the cosine difference identity. Okay, this is an important identity that gets used in trigonometry a lot, but also calculus, physics, engineering, among lots of other things. Okay, so let's start just remembering that we're going to take a look at the unit circle and an angle theta and phi in standard position on the unit circle. Let's suppose that these represent points x2, y2 for theta and x1, y1 for phi. All right. Okay, now what the usual strategy here is to consider the distance between these 2 points. Okay, so that line that I've just drawn there. Okay, the distance between those 2 points, let's call that d. Okay, and what we'll find out here is really not necessary to find d. Finding d squared is going to be good enough. Okay, so d squared. Okay, we'll just use the Pythagorean theorem, or the distance formula, essentially. Okay, let's take the difference in those x coordinates squared plus the difference in the y coordinates squared. Okay, now we have to remember that on the unit circle, x coordinates are always equal to the cosine of the standard position angle, and the y coordinates are equal to the sine of that angle. So x2 is equal to cosine theta, x1 is equal to cosine phi, okay, and then that binomial gets squared. Similarly for the y coordinates. Okay, so let's just FOIL those out, okay, which we know how to do. So I'm going to take the square of the first term minus, in this case, 2 times the product, cosine theta, cosine phi, and then the square of the last term. Okay, let's do the same thing with that second binomial. So we're going to get sine squared theta minus 2 sine theta sine phi plus sine squared phi. Okay, what we notice now is that if we reorder these, I'm not going to actually reorder them, but if we just imagine the cosine squared theta and sine squared theta together, well, that sum is equal to 1. Okay, and we have a very similar thing going on here with the sine squared phi and cosine squared phi. All right. So d squared. Okay, we'll have a 1 from one of these sine squared, cosine squared pairs, and I'll have a 1 from the others. Okay. All right, my 2 remaining terms each contain a negative 2. All right, which I'll factor out of the binomial cosine theta, cosine phi, plus sine theta, sine phi. Okay. And then finally, well, we can factor that 2 out or not. I think I'll just leave it there. Okay. All right, so next, we're going to leave that as it is, but next what we're going to do is consider the same thing, but with the angle, basically the triangle you see in the picture, rotated clockwise by an angle phi. Okay. All right, so now I've created a new screen for us here. This is basically the same picture. The 2 red radii of the circle have been rotated angle phi clockwise. Okay, so the angle between the 2 red radii in the first picture and in this one are both theta minus phi. As before, we can sketch a line segment between these 2 points, and it will still have a length equal to d. Okay, it's essentially the same triangle, just rotated rigidly. Okay, so now let's find a formula for d in terms of this setup. Okay, well, the idea, once again, is to use the distance formula, which amounts to the Pythagorean theorem. Okay, so in this picture, that's going to be x sub 3 minus 1 squared plus y sub 3 minus 0 squared. Okay, as before, the x's and y's stand for, or can be replaced with the cosine or sine, respectively, of the standard angle, which is now theta minus phi. So in this first grouping, I have cosine of theta minus phi minus 1 squared. In the second grouping, it's just y3 squared, or sine squared of theta minus phi. Okay, well, let's expand out that first binomial as we did previously. Cosine squared theta minus phi minus 2 cosine of theta minus phi plus, plus 1 plus sine squared theta minus phi. Okay, now what we're seeing here is I have a cosine squared plus a sine squared of the same angle. That combination is equal to 1. Okay, so altogether I have that one plus the 1 that came about from the binomial square. So I have 2 minus 2 cosine theta minus phi. That's d squared. Okay, however, previously we derived that d squared was equal to 2 minus 2, and in the grouping, cosine theta cosine phi plus sine theta sine phi. Okay, and if we take a closer look at things, we see that d squared is equal to 2 minus 2 times something else. Okay, in the case we just finished, that something else was cosine of theta minus phi. And previously, that something else was cosine theta cosine phi plus sine theta sine phi. Okay, so what we're finding now is if d squared is equal to d squared, which it should be, then we're finding our cosine difference identity to be cosine theta minus phi equals cosine theta cosine phi plus sine theta sine phi. Okay, when I write identities, trigonometric identities, I often like to use that triple line equal sign, which is a stronger statement than merely an equal sign. Okay, it means that this relationship is true for every possible value for either angle that you can choose. It's not an equation to be solved for a variable. Rather, it is something that's true for all possible values of either variable. Okay. Well, I hope this has been helpful. Okay, stay tuned for more videos like this, trig identities, maybe some physics and engineering related things, or something from calculus, or who knows what else. Just lots of other cool stuff. Thanks for watching, and see you soon.